Hello everyone, welcome back to the channel. Today we will secure our GWT token, the same thing as we have done under the Kotlin or Jetpack Compose application. But this time we're going to use keychain to secure our GWT token. You can think of keychain like the place where we store small data but sensitive data securely. It is basically a secured system managed storage. Under util, create a new folder. Let's call it crypto. Add a new file. Let's call it crypto service. It will be a public protocol, the first function, which is to save data and to load data. Now we have to implement this particular protocol. Where do we start from here? First of all, what we have to do here is to convert the string token to the data using UTF-8 encoding. Therefore, we have to do here a guard because it can't be null. Let's convert the token by doing token data equal token and data using UTF-8 encoding. And if it fails to provide this value, early return. Next, we have to create the query dictionary required by the keychain API. First of all, we have to define the kind of keychain item. It's a generic password in this case. Next, we have to specify the attribute service. Identifies our application service in a unique manner. Basically, we're not gonna hard code this service. Let's create here a private let. Let's do here just the package or the namespace for our application. This is basically the keychain service name used to uniquely identify our application stored items. Next, we have to specify the account. It is an attribute that defines the user or the item key. In our case, it's the API token. Account as string. Hence, we have provided here the key, which is the string, and the values are any. I'm not gonna hard code this as well. I'm gonna do here private let account. Let's name it API token. The account by adding here API token. The last thing that we have to define here is basically the value data. The value data is the actual data to be stored. In our case, it's the GWT token. Value data as string. We have the data converted to the UTF-8 encoding. We're going to add it here, token data. Now we have the query. What we should do basically is to add the new token item to the keychain. But beforehand, we need to delete any existing keychain item with the same service account before adding a new one. How to do so? We're going to call the function item delete, and we have to convert it to CF dictionary. And next, we're going to add a new item by calling the function item add. What we have to pass here, the query as, the query as CF dictionary. And we have to specify here null. By passing null here, it means that we have passed the result, kind of status code. In our case, doing null here, it means success. Now we have to load or decrypt the data. Now, in order to load the data, we need to try to find the token in the keychain by providing the query and the result. Now let's construct the query, and we have to provide here the needed criteria. Basically the same thing that we have done here. It is the generic password item, the attributes, pretty much the same thing as well as the account. Now what we have to do here is to specify the return data. It is a request to the actual token data to be returned. Return data as string and true. By specifying true, it tells keychain that we are requesting the actual token data to be fetched in the keychain. The last parameter that we have to provide here is the match limit. It's simply the amount of result that we want to retrieve. And for us, it is only one item. One, which is keysec match limit. We have a lot here, but we are interested only in one item or one value. Now we have the query. What we should do here is to get the results by doing item copy matching. And we have to pass here the query. And for the result, we need to pass the result here or to create the result to be stored. Basically, the result, it's going to be a variable to store the results of the keychain search. It's going to be of type any object. And we have to pass here the address of this result. Next, we have to store this in a status, and we have to check on status. If the status is success, we'll try to convert the data back into a string by doing sec success. Next, we need to get the data from the results, and because it is nullable, let's store it under data result as data. We're going to cast it to data type. Now we have the data. We're going to convert this data back to the string by doing let token equal string. And we have in the constructor of string, the constructor providing the data in the arguments, and the encoding here, it's going to be UTF-8. In this case, what we should do, we will return the token. This is basically the token that we have saved before. Now, if we're not under the success status, in other words, the retrieval failed or the data is missing or corrupt, we will return null. As you can see here, it's not that complicated in comparison to the version that we have implemented under Kotlin, and I like the implementation so far. I think that's pretty much it for today's video. For the next tutorial, or for the next video, we have to implement the mocking of our services for testing purposes. The same thing that we have done under the Kotlin application. I hope you liked the video. See you in the next one, and happy coding.